Hello all. In this video we are going to discuss all the numericals from grade 9 ICSE Selina textbook, and the name of the chapter is light. So here I have a concave mirror and this is a convex mirror, and we are supposed to go through the concept of sign conventions very fast, because if we don't understand the sign conventions then the numericals will be extremely difficult for us to solve. So always remember one thing, that whether the mirror is concave or convex, you need to keep the object on the left hand side of the mirror like this. Now this is the concave mirror, the reflecting surface is inside and this point is pole. Again over here the reflecting surface is outside and this is the pole. You must be very careful that pole of the mirror should be at the origin of the coordinate system. So this is our x-axis, this is our y-axis, and the pole is at location 0, 0. In the same way, again I am going to draw a y-axis passing through the pole. So I am going to call the pole as the origin. And now all the distances on the left hand side, this is the left hand side of the origin and this is the right hand side of the origin. So all distances on left hand side of the origin would be negative and right hand side would be positive. Now in the textbooks it is given that if the distances are opposite to the incident ray, the distances are to be considered as negative and all distances are measured from pole. But you can also simply understand in this way that all distances on the left hand side of the pole are negative and on the right hand side are positive. Another thing, this is the height of the object, the distance from here to here. This distance, since it is above the principal axis, it has to be considered positive. And if I say that suppose this is C, the midpoint is F. So if the object is beyond C, the image is between F and C and smaller than the object, diminished. And if I call this as HI, then HI is the height of the image which falls below the principal axis. So this has to be considered as negative. Same the case with the convex mirror, that we know the image is always formed between, suppose this is C, this is F. So image is always virtual and direct and between F and P. So here the height of the object will be positive, height of the image will be positive because both the heights are above the principal axis. Another most important part is the object distance. This distance is the focal length. This distance is radius of curvature. This distance is object distance. And this distance is the image distance. You can see that all distances in this particular case lie on the left hand side of the pole. So U is negative, focal length is negative, radius of curvature negative, and image distance is also negative. Whereas in this case, in case of the convex mirror, object distance is negative, image distance would be positive because it is on the right hand side of the pole or the origin. Focal length is also positive, radius of curvature is also positive. So our most important learning is, whenever we have concave mirror, the focal length will be negative. Convex mirror, focal length would be positive. Height of the object in either of the case always positive. Object distance always positive. Now image distances could be positive, negative depending upon the virtual or the real image. If it is a real image, it will be in front of the mirror in case of convex, in case of concave mirror, and it will be regarded as negative. If the mirror is convex and if it is a virtual image, it will be formed behind the mirror and the image distance will always be positive. So taking these things in mind, we shall move ahead and understand the numericals. Now, a radius of curvature of a convex mirror is 40 centimeters. Find its focal length. Now this is our convex mirror, so the reflecting surface is outside and the painted surface is inside. I may call this as C, this as the midpoint F, this point as pole. Now I may choose to pass the y-axis from the origin of the coordinate system, and I can see that focal length is on the positive side of the x-axis. So my focal length and the radius of curvature both will be positive. And we know radius of formula is twice the focal length. The radius of curvature is given to us as 40 centimeters. So that is twice into f. So focal length is equal to 40 centimeters by 2, and that is plus 20 centimeters. Or you may also choose to write down 20 centimeters behind the pole. This is our answer to the first problem. Now we have a concave mirror. Again, I should draw the origin like this, passing from the pole, and the reflecting surface is inside and the painted surface is outside. Focus, center of curvature, and both my answers will be, of course, negative, focal length and the radius of curvature. And since focal length is given to us as 10 centimeters, so if I double the focal length, radius of curvature is twice the focal length. So radius of curvature would be twice of the focal length is minus 10 centimeters. So my answer would be minus 20 centimeters, or you can also write down 20 centimeters in front of the mirror. Generally in the answer, they do not use negative sign, they just simply write the magnitude, but we should be very careful that it is negative 20 centimeters, even the focal length is also minus. So you can choose to write down any one of these and it will be regarded as the correct answer. Now here again, this is our origin. This is pole, reflecting surface inside. This is C, this is F. Now they are giving the data that object distance is 20 centimeters, focal length is 12 centimeters. Now this distance is plus 12 centimeter, this distance is plus 24. I'm sorry, I made an error. As per the sign conventions, these distances has to be negative. Because they fall on the left hand side of the mirror. Now the object is placed at a distance of 20, that means somewhere between 12 and 24, because the focal length is minus 12 centimeter, radius of curvature is the double, so minus 24 centimeter, and the object has to be kept on the left hand side of the pole, so the object distance is minus 20. You can understand that this 20 lies between 12 and 24, so the object is between F and C. And the height of the object is also given to us, and since the objects are always upright, its distance will be considered as plus 2 centimeters. So HO we know, and as per the ray diagrams, we should understand that the image will be somewhere behind the C, beyond C, and the height of the image should be negative and enlarged. Correct. So my answer of the image distance, because this is our image distance V, so answer should also be negative. At the end, this is U. So let us apply the mirror formula, which is 1 upon F, that is 1 upon U plus 1 upon V. Now focal length of the concave mirror are negative, minus 12, 1 upon minus 20 plus 1 upon V. Transferring this on the other side, taking the reciprocal, I am getting the image distance as minus 30 centimeters. This is my first answer. Now they are asking us this position of the image, which is the image distance. The size of the image means the magnification, so I may choose to write the magnification here. Magnification is equal to minus V upon U, and minus, you have to make sure that while you use any of the formulas in this chapter, sign conventions are to be used, because formulas are without sign conventions. And V is minus 30 divided by U is minus 20. So minus minus gets cancelled, 0, 0. It is minus 3 by 2 or minus 1.5. Second answer. Now, nature of the image, if the magnification is negative or the image distance turns out to be negative, which is the case over here, that image distance is minus 30, that means it is on the left hand side of the pole. And always the real images are formed on left hand side of the mirror. So that means this negative image distance indicates it's a real image. I may also choose to find out the height of the image. So magnification is height of the image upon height of the object, which we already know is equal to minus 3 by 2. So hi upon ho is plus 2 centimeter, that is minus 3 by 2. So hi will be minus 3 by 2 into 2 centimeters. So my answer of hi again is plus 3 centimeter. Moving to the next problem. Here, focus, center of curvature, pole. Again, I am going to consider the pole as the origin. Mirror should be at the pole. The pole of the mirror should be at the origin, and object should be at the left hand side of the mirror always. The object distance is 4 centimeter, which is negative. Radius of curvature is again minus 24 centimeter. You can see from here that radius of curvature lies on the left hand side of the pole, and pole is the origin. So focal length is half, that is minus 12. And you can see that the object distance is less than the focal length. So object would be between F and P. Correct, because this distance is 4 centimeters and the focal length is 12 centimeters. So the object distance is less than the focal length, which clearly indicates the object is between F and P. Under this scenario, you will get a virtual and direct image behind the mirror. But let mirror formula do that for us. So I should get my answer of V as positive and Hi also as positive. Height of the object is always positive. Always understand one thing, if the magnification is positive, it will be a virtual image, and if magnification is negative, it should be a real image. Correct? Okay. So let us find the position of the image first. Position means the image distance. So 1 upon F is 1 upon U plus 1 upon V. The 1 upon minus 12 is equal to 1 upon minus 4 plus 1 upon V. Solving further, 1 upon minus 12 plus 1 upon 4, 1 upon V. Here the image distance is positive, which means that the image is formed on the right hand side of the pole, and always right hand side of the pole or behind the mirror, virtual images are formed. So the image is virtual and upright or erect. Now, is the image magnified? So we can find the magnification. Of course, it has to be magnified and the magnification should be positive. Now here height of the object and height of the image are not given. Actually, height of the image is not given, so we can use minus v by u. So minus v is plus 6 divided by minus of 4 centimeters. And magnification doesn't have any unit because centimeter gets cancelled. Minus minus cancels, 2 3s are, 2 2s are. So magnification turns out to be plus 2, and even you can find out the height of the image, hi upon ho is equal to plus 2, and hi upon ho is 2 centimeters positive, that is plus 2. So the height of the image over here will be plus 4 centimeters. Moving on to the next problem. Here, at what distance, that means we are supposed to find out the object distance u. This is pole. From the concave mirror, focal length is given to us as 25 centimeters, which has to be negative. An object be placed so that the size of the object and the image are same. Of course, as per the ray diagrams, this object should be at C, because the height of the object is equal to the height of image when the object is placed at C, and C is placed at a distance of now C is at a distance of twice the f, so radius of curvature is minus 50 centimeters, and since the object is at C, the object distance is also minus 50 centimeter. But if you are being asked to prove mathematically, we can use this concept. Magnification is equal to hi upon ho. Now hi has to be negative the ho, because the height of the object and image are same, but the height of the image is negative because it is real and inverted. So the answer is minus 1. We are going to use this trick. So magnification is minus 1, which is equal to minus v by u. Minus minus cancels, so we have v is equal to u. I'm going to use this in the mirror formula. Instead of v, I'm going to write down u. So substituting the value, I'm going to get the object distance is equal to the image distance, which is minus 50 centimeters. This is our answer to the problem. We move on to question number 6. Here we have an object which is placed at a distance of 5 centimeter. So we move on to the next question. The object is placed at a distance of 60 centimeters. This is the pole. The height of the object is given. The focal length, suppose this is f. So this is 10 centimeters. Of course, it has to be negative. So the radius of curvature should be double the focal length, 20 centimeters. And then you have an object which is thrice the distance more than the radius of curvature. So I am going to make an object over here. This distance is 60 centimeters. The height of the object over here is plus 5 centimeters. Of course, all these distances, focal length, radius of curvature and object distance, since they lie on the left hand side of the pole, are negative. We are supposed to find out position of image, that means image distance, magnification, size, and of course the nature of the image. And we know that as per the ray diagrams, my answer would be between f and c. The image would be of course real and inverted. So let's apply the mirror formula first. Focal length is minus 10, object distance is minus 60, plus 1 upon v, taking on this side and solving further. As expected, our answer should be between 10 and 20 because the image should be formed between F and C, and the image should be on the left hand side of the pole or the mirror. So we are good to go over here. This is the first answer. Now let's find the magnification, that is minus V upon U. We have to use sign conventions in all the formulas that we use. V is minus 12, U is minus 60, 12 ones are, 12 fives are. Then answer is minus 1 upon 5. Now if I am supposed to find the height of the image, I can do that. Height of the image upon height of the object is magnification, which is minus 1 upon 5. Height of image I don't know. Height of the object is plus 5 centimeters as it is above the principal axis, that is minus 1 upon 5. So height is minus 1 centimeter from here. We can solve and find the answer. And of course the image distance is negative, so image is in front of the mirror. So the nature of image is real and inverted. An object is kept at a distance of 40 centimeters. Now this is our convex mirror. Now pole is at the origin. Now you can see that the object distance is again negative because the pole should be at the origin of the coordinate system. But the focus over here lies on the right hand side as the radius of curvature also. So the focal length should be positive. Radius of curvature should also be positive. Focal length is 40 centimeters. So plus 40 centimeters, radius of curvature would be double the length. Now here again 1 upon f is 1 upon u plus 1 upon v. Now focal length this time is plus 40. Object distance is minus 40. Plus 1 upon v. We should know that the image should be between pole and the focus, and it should be, this is the pole, so the image has to be smaller than the object and between p and f. So our answer v should be positive. So I am going to shift this minus 1 upon 40 on the other side. It becomes plus 1 upon 40. So 2 upon 40 is 1 upon v. So v is equal to plus 20 centimeters, and my answer should be less than the focal length. So this is correct, right? So the position of the image is nothing but the image distance. Question number 8. The height of the object is given to us. The object distance is 4 centimeter. So let me draw the pole again. This is 0, 0. And the focal length is not given to us, but the object distance is given, and the object is placed at a distance of, this is height is plus 1 centimeter, and it is placed at a distance of 4 centimeter, right? But they have given us that the image is formed behind the mirror like this, and this is height of the image, and the image distance is 6 centimeters, right? So image distance would be positive since it lies on the right hand side, object distance negative. Now I know that the focus should be somewhere over here, because if the object is between f and p, then and only then you are going to get the image behind the mirror. So my answer of focal length should be more than 4, right? So let us apply the formula. 1 upon f is equal to 1 upon u plus 1 upon v. 1 upon f is 1 upon u is minus 4 plus 1 upon plus 6. Solving further. Our answer is minus 12 centimeters. Question number 9. The object height is given, distance of the object is given, focal length is 15 centimeters, and of course this is a concave mirror, so this is minus 15 centimeters. Now the center of curvature doubles, so minus 30 centimeters, and the object is placed at C, because the object is kept at a distance of 30 centimeters. So again, as per our ray diagram method, we know that the image should be formed at C, so image distance should also be negative 30. But let's apply the formula and find the answer. So our image distance is also minus 30 centimeters, mathematically proved. Question number 10. You need to be very careful over here. No data are given. U is not given, V is not given, and we are supposed to find out F. If these kind of questions come when object distance and image distance are not given, you should take the help of magnification. And whenever the real image is given, the magnification has to be negative, right? And they are also giving us 3 times, so the magnification should be -3, but let us understand how. They are asking us that the height of the image is 3 times the height of the object. So HI is 3 times HO, and since it is a real image and real images are below principal axis, so this has to be negative. So HO cut, you are getting magnification as -3. Now we know magnification is minus V upon U, and that is equal to -3. So minus minus cancels, V is equal to 3U. Now this is what I am going to use it in my mirror formula. So mirror formula is 1 upon F, 1 upon U plus 1 upon V, 1 upon F, that is 1 upon U, and V can be written as 3U. So this is 1 upon F, that is equal to multiplying 3 and 3 up. So this is 3 upon 3U plus 1 upon 3U. So my answer is 4 upon 3U. So doing the reciprocal, focal length is equal to 3U upon 4. Correct. Now they are asking us that the object is at a distance of 30 centimeters. So object distance is given to us as minus 30 centimeters. So I'm going to substitute the value over here, 3 by 4 minus 30. So my answer would be 90 by 4, so it is 22.5 centimeters. Of course it would. Question number 11 says that there is a virtual image formed whose height is double the size of the object. Object distance is also given to us, and in case of concave mirror it is only possible if the object is between F and P. So if I keep an object of height HO, the image will be formed behind the mirror, virtual and direct, and its height is double the height of the object. Now both the heights are positive, so of course the magnification would be positive in this case. The pole is at the origin. Object distance is given to us as minus 5 centimeters. 5 centimeters to the pole on the left hand side. So I am given U, that is minus 5 centimeters. I am supposed to find out the focal length. Now we are not also aware about the image distance, but I can assure you that we can find with the help of magnification, that is HI upon HO. Height of the image is twice the height of object, positive. Of course height of the object is also positive. So magnification is +2, but magnification is also equal to minus V by U, that is +2. So here minus V is equal to twice of U. So V is equal to minus 2U. Now I am already aware that the U value is 5 centimeters. This U has to be negative, so V is equal to plus 10 centimeters. So I know the image distance as well, plus 10. Now I am going to use the mirror formula. 1 upon F is 1 upon U plus 1 upon V. So 1 upon F is equal to 1 upon minus 5 plus 1 upon plus 10. So I am going to multiply this up and down by 2. So minus 2 upon 10 plus 1 upon 10, that is equal to minus 1 upon 10 centimeters, that is 1 upon F. So focal length of the mirror is minus 10 centimeters, but in answer you may find it as plus 10 centimeters. because they don't use sign convention while writing the answer. This is the more accurate answer. You can also write this answer as 10 centimeters in front of the mirror, or focal length as minus 10 centimeters. That is the position of the image. In question number 12, we are being given that the image is 1/3 the size of the object. So we know that height of the object is always positive, and here the image is always between the pole and the focus, and the height of the image is 1/3 the height of the object, and the image is virtual, so the magnification has to be positive. First of all, let's find out how. So magnification is hi upon ho, and magnification is 1/3 of the height of the object, which is positive, and here ho is also positive, because in case of convex mirror the image and object both are erect. So my answer would be magnification is equal to +1/3. Now I can use this formula, minus v upon u is equal to 1/3. On cross multiplying, minus 3v is equal to u. This is the answer to the problem, the relationship between u and v. Moving ahead, here we have an erect image which is only possible if the object is kept between f and p. The image will be behind the mirror, height will be positive, height of the object is always positive, magnification will be positive. Now here they are asking that double the size of the object. So magnification is hi upon ho, but height of the image is double the height of the object, and it is a virtual image, so it will be erect, so positive. All distances above principal axis are positive. Again, magnification is +2, so magnification is minus v upon u, that is +2. On cross multiplying, minus v is equal to +2u, or simply minus v is equal to 2u. This is the answer to the problem. The last case, the magnification is already given to us as -3. Now this is only possible. See, this negative sign indicates that image is real. Correct? So the image has to be bigger than the object 3 times, and that is only possible if you place the object between f and c. So height of the object ho, height of the image will be 3 times the height of object, but negative. How come? Because it is formed on the same side of the mirror, and real images are always inverted, and inverted images are below the principal axis, so it comes with a negative sign. So minus v upon u is -3, minus sign gets cancelled. On cross multiplying, v is equal to 3u is the answer to the problem.